So to wrap up the meteorology unit completely, we're going to talk about the circulation of the atmosphere using the 5-image story for homework 4. So to start off, we're going to talk about the direction of wind. Wind likes to go from a high pressure gradient to a low pressure gradient. This is because in a high pressure gradient, there are more air molecules, so it feels crowded, and so they are trying to get to a low pressure gradient where the air molecules are lesser and they feel less crowded. So as you can see from this image, here is what a high, or this is the H, high pressure gradient, and all these arrows you can see are moving up, outward, away from the H, or the high pressure gradient. And then they're going over to the lower pressure gradient, and all of these arrows in this image are moving inward. So the greater the difference in pressure, the stronger the wind. So in this image, the wind right here would be much stronger than, say, the wind over here or the wind over on these sides of it. Moving into the Coriolis Effect, which is the rotation of the Earth has an effect on the direction of the wind. So wind moves in a straight line, but due to the direction of rotation and the way that it's constantly moving, it can't move in that straight line. So this, again, is called the Coriolis Effect. This affects the wind direction, not the wind speed. So because of this, the wind direction isn't always going to be from high to low. So as you can see in these arrows, in the northern hemisphere, which is the top half up here, we can see that if we are in a low pressure gradient, the wind is trying to move to the wind is going to be moving to the right, even though it's trying to move straight. And if we were in a high to a low pressure gradient, the wind is going to move into the left. Looking at the southern hemisphere, if we were in a low pressure gradient and moving to a high pressure gradient, that wind is going to start moving to the right. And back over to, if we were in a high pressure gradient, moving to the low pressure gradient, that wind is going to be moving to the left. So it's dependent on your hemisphere, and it is dependent on if you're moving from low to high or high to low, if it's going to be moving in counterclockwise or clockwise. Next, we're going to be talking about friction and how friction plays a part into the circulation of the atmosphere. So friction reduces the Coriolis force, so it changes the wind direction. So as you can see from this image, the Coriolis effect is taking this high to low, and it is moving it to the left, or yes, in this image it's moving to the left. The friction that comes from the wind surface is going to turn it the other way. So it moves in the opposite direction, which actually slows the wind down. And actually, looking at this map, we can see that the isobars, which are these lines right here, are showing us that the wind pressure would be, the wind speed would be weak because they are farther apart. The closer that they are, the wind speed would be greater. Moving on to the circulation direction. In the images below, you can see a cyclone on your left, right here, and on the right is an anticyclone. So for cyclones, these are low pressure gradients. They are where air is converging and moving towards the inward section of the cyclone. It produces extreme weather such as tornadoes and things like that. And an anticyclone excuse me, is in a high pressure gradient, meaning that it is moving outward, trying to get away from that middle section. This is where mild weather is produced and the air is diverging away. Lastly, we're going to talk about weather fronts and how the weather fronts are affected from this type of circulation. So looking first at the cold front, the cold front is a mass of cold air coming into a warm air, low pressure system. The direction of the front is moving to the right in this image, and we can see that the cold air is coming into the warm air while the warm air is rising. Looking at the warm front, we can see that this is when a mass of warm air is coming back over that cold air. An occluded front is when cold air mass is meeting up with the previous cold air going over this warm air mass. And a stationary front is when cold air and warm air fronts are not moving anymore and nothing's happening. So that's wrapping up this section of the meteorology unit. Hope there was something that you took away, and thank you.